This section is on using formulas to find areas of rectangles, parallelograms, and triangles. So first of all, let's look at rectangles. Here we've got a rectangle, quadrilateral, and it's got 4 right angles, as you can see, and find the area. Length times height, or length times width, base times height, either way. One side times the other. A couple of quick examples. So 3 miles by 9 miles is 27 miles squared. It's an area, so it's always in units squared. Now let's look at parallelograms. Actually, we'll look at squares briefly. For a square, because the length and the width are the same, you can just square it, hence the name squaring actually. So for square, it's just sides squared, though you could still do length times width. Of course, they would just be the same thing. So one example of that. So 4 by 4, of course, is 16 meters squared. Okay, back to the menu. We'll look at parallelograms. So parallelogram, opposite sides are parallel, in addition to, of course, many other properties which we've discussed. To find the area of a parallelogram, area of a parallelogram is base times height. Notice it's not one side times an adjacent side. The height is perpendicular. It's an altitude. It goes from one side down to a right angle. As to why this is so, it can be seen as basically a rectangle which has been shifted over. So you can see you can pick up part of it and move it over. Now you've got yourself a rectangle. So then an example of this, and we'll look at some more challenging examples later. So base times height, 7 by 4, 28 feet squared. Okay. And lastly, triangles. And here's the area. So you've got your base. Your height, again, is from an altitude. It's a vertex down an opposite side, down to the base, that is, and makes a right angle. And as far as why this is the case, well, if you take another triangle just like it and flip it over, you get a parallelogram. So this is half the parallelogram's area. So half times base times height. So base is 11, height is 6, half times 6 times 11. Again, it's in square units. Base is 12, height is 6, half times 6 times 12. 36 square feet. Okay, again we see, let's take a look at parallelogram. With parallelogram, you can see how the parallelogram is here in blue. It corresponds to this rectangle, which is in purple, and you see how basically this this triangle here is equal to this one. So no matter how we move this around, the base is always staying the same, the height's the same, so this long, thin parallelogram will be the same as the rectangle. We see the same idea with triangles. This triangle, the area is listed here. Here's the perimeter. I can move this point around, and the perimeter may change slightly, but the area doesn't because the base and the height are staying the same. Now, something to note is that for a right triangle, you can draw in your height as one of the legs, as you see right here. And for an obtuse triangle, it's an altitude, that is the height, so it's outside the triangle. Now notice that the area is not changing here. So even though the perimeter is changing, it's getting much bigger, the actual area is not changing. Okay, going back and looking at some formulas now. Just to review all of these for today, for this lesson. We've got the area is side squared, rectangle's length times width, parallelogram base times height. Though really, base, height, length, width, those are kind of interchangeable. Triangle is half times base times height, or you can do base times height divided by 2. So now some examples. Okay, a parallelogram has a height that is 5 inches less than its base. So first thing I do is I draw a parallelogram. I draw in the base and I put a height in. So height goes from one side and perpendicular to the other. And I make the height b minus 5 because it's 5 less than the base. The area is 50. So given that, we want to find out what the height and the base are. So I have base times height, so b times b minus 5 is equal to the area. And then I do the algebra, so I distribute to get to here. And you have to get 0 on one side. Then we factor it, which gives us answers of base is either 10 or negative 5, but you can't have a negative length. That doesn't make any sense. And so we just leave with the answer that the base is going to be 10. And if the base is 10, the height is base minus 5, so that means the height is 10 minus 5, which is 5. Okay, another example. Okay, over here we have the length of a rectangle is 1 centimeter less than twice its width. So here's the width. The length is 1 less than twice the width, so 2w minus 1. The perimeter is 82. Okay, if the perimeter is 82, now I know that this is also going to be w. This will be 2w minus 1 as well. So the perimeter is adding up everything. So what I have is 2 of each of these. So I've got 2 w's, and I've got 2w minus 1's. So I can do 2 times those things. So I lost my rectangle. All right, so then to solve this, I'm going to divide both sides by 2, and this becomes 3w minus 1. I'll add 1 to both sides. W is 14. Once I've got w, I can plug it in here to get the length. So length is 2w minus 1, which ends up being 27. And to get the area, again, it's length times width, or base times height if you prefer. So length times width, 14 times 27 was 678, and it's centimeters squared. Okay, to do these problems, a lot of times we involve other things. In this case, it involves the Pythagorean theorem. If this is 16 across and it's an isosceles triangle, we know this is going to be 8. And so to get the height of the triangle, 8 squared plus h squared is equal to 10 squared. So h squared is 100. 10 squared is 100 minus 64, because that's what h squared is. So that's equal to 36. Therefore, h is equal to 6. So the triangle is 1/2 times the base, which is 16, all the way across, times the height, which is 6, which is equal to 48. Now, parallelogram. If this is 3 and this is 5, this is the height, so 3 squared plus h squared is equal to 5 squared. This is a 3, 4, 5 triangle, or you can do the Pythagorean theorem. And so the area is equal to the base, which is 12, 3 plus 9 is 12, times the height, which is 4, so 48 in this case as well, coincidentally. Okay, more practice. All right, for these first few problems, you're trying to find the area of each triangle, and so the area formula is 1/2 times base times height. So you simply do 1/2 times 8 times 2, which is 8. 1/2 times 20 times 6, which is equal to 60. I think you get the picture there. So we'll skip number 9. Now getting down to number 10, it's a little trickier. We can find the area of a parallelogram by doing base times height. So what we can do is a couple different things. We can say that we have a base of 10 with a height of 7, and so 7 times 10 is equal to 70. And we can also do a base of 8 with a height of h, and so that must equal 8h, because either way you're going to get the area, whether you use base height here or base height here. You know it's going to be 70, so I can get this equation 70 is equal to 8h, and so h is 70 divided by 8, which you can reduce, get some decimal. Same idea over here. We can use this height along with this base. We don't use the dashed line, so 11 times 14 is one way to express the area. And then another way to express the area is this base here and this height. So that's equal to 22 times h. And so then if you divide 22 from both sides, these cancel. 11 and 22 cancels to just a half down there, and so h is equal to 7. Okay, a few more problems. We want to get the shaded area. The fact that this is 5, so what? Doesn't really do anything for us. Area is 1/2 times the base. The base of the triangle is only 4 times the height, which is 8. Over in 16, we've got two triangles. So for this one over here, it's 1/2 times 11 times 14. It's a right triangle, so you can choose either one to be the base or the height, plus 1/2, and for this triangle up here, 1/2 times 14 times 6. So you add those two together. Over here, if the whole thing is 13, this is 4, this is 5, so together these guys are 9. 13 minus 9 is 4. So it's 1/2 times a base of 4, this 4 here, times a height of 6. Now, these problems with coordinates, easier than they may look at first. You want to do a base times a height. And because these things are set up horizontally, these bases, it's pretty straightforward. So to go from -6, -4 to 0, -4, you have to go over 6, because -6 to 0 is 6. To go from this lower level to the upper level, this is at a height of -4. This is at a height of 4, so you have to go from -4 up to 4, which is 8, and 6 times 8 is 48. Over here, let's say we make our base over here, and our height is again just the distance between the two. From -5 to 3 is 8, and from 0 down to -5 is a distance of 5, so 8 times 5 would be 40. If you don't actually have a drawing and you just have coordinates, such as in something like these two problems here, simply draw something, and then you can do it the way I showed the last one. Though note that you have to make sure that you realize what kind of figure you have. This is a parallelogram in this problem. This is only a triangle.